Okay, students, so let's get started with past papers today. Today we are going to do O levels and IGCSE physics past papers for forces. Let's start with question number one. A tractor pulls a trailer at constant speed. Okay, so this tractor is pulling a trailer at constant speed. Okay, the tractor exerts a force of 1600 Newton forwards. Okay, so there is a 1600 Newton force in the forward direction and you are moving at constant speed. Okay, what force is exerted by the trailer on the tractor? So basically we have to calculate how much force is exerted on the backside to have a constant speed. Do you remember whenever you have constant speed the resultant force is equal to zero? The forward forces are equal to the backward forces. What is the forward force here? 1600. So the backward force will also be 1600. B is your answer. Let's move to the next question. A car travels on a horizontal road along around a straight bend at constant speed. Okay. So let's say this is your circular bend and let's say the car is traveling along this bend. Whenever anything is moving in a circle, the resultant force always acts towards the center. Whenever anything is moving in a circle, the resultant force always acts towards the center. C is your answer. Let's move on to the next question. A car of mass 1000 kg is traveling down a steep hill. Okay. The brake fails and driver uses a horizontal sand filled safety road to stop the car. Okay. The car enters the sand at a speed of this and experiences a constant stopping force of this. Okay. So this is the stopping force. This is the mass of the car. This is the initial speed. The final speed of the car is zero because it is coming to rest. Okay. Can you calculate the value of deceleration? Yes, F is equals to ma. What is your force? 2500. What is your mass? 1000 kg. What will your value of deceleration come out to be? 2.5 ms minus 2. Remember that this is deceleration. This is deceleration, or you can say negative acceleration. Why? Because your speed is decreasing from 0 to a value from your speed is decreasing from a value of 10 to a value of 0. Okay, now let's take this value of deceleration and calculate the time to reach from 10 to 0. V is equals to u plus 80. What is your V? 0. What is your u? 10. What will you write in place of acceleration? Minus 2.5 because this is deceleration. This time comes out to be 4 seconds. So basically, if your car is hitting the sand filled road, a sand filled safety, it will take 4 seconds to come to rest. Okay. Can you calculate the distance traveled during this 4 seconds? Yes, you surely can. What will you do? Average speed into time. Now, why I have taken average speed and not only speed? Because can you see the speed is changing from 10 to 0. So I can't take a singular speed. I have to take an average of them. 10 plus 0, initial plus final divided by 2 multiplied by the time that is coming out to be 4 is equals to your distance. 5 into 4 is equals to 20 meters is equals to your distance. C is your answer. Let's move on to the next question. A solid object immersed in water hangs from an elastic thread. Okay. Three forces act on the object: its weight, the tension in the thread, and the force from the water. Okay. So the weight will act downward. The tension always acts away from the object, and there is an upward force. Okay. Let's see what else is written. Which equation is correct when the object is stationary? So when you are stationary, your resultant force is equals to 0. Up forces is equals to the down forces. What are the up forces? The you can say the examiner has labeled this up force as F. So let us also label this up force as F plus T is equals to the down force, that is W. Can I bring w to the left hand side? Yes. F plus t minus w is equals to 0. Is there any option like that? D is your answer. Let's further move ahead. A coin falls from rest, okay, through air and eventually reaches a constant speed, okay. So a coin was starting from rest, that is u is equals to 0 and eventually reaches a constant speed, okay. There is a resultant force acting on the coin due to the two forces P and Q, okay, shown in the diagram. What happens to force P and what happens to resultant force before the coin reaches constant speed? So do you remember this upward force or the backward force is air resistance? And air resistance is constantly increasing until you reach terminal velocity or constant speed. So A and B options will get cancelled out. What happened to the resultant force? What will happen to the resultant force? Resultant force will decrease. Resultant force will decrease as air resistance increases. C is your answer. Okay, let's see this. A hot air balloon is traveling at constant velocity and is at a constant height above the ground. The diagram shows the only four forces acting on the balloon. Which statement is correct? Okay, so it is moving at constant velocity. That means the resultant force will be equal to 0. That means the up forces will be equal to the down forces and the right forces will be equal to the left forces. Okay, what is your up force? X. It should be equal to Z. X should be equal to Z. And Y should be equal to W. Y should be equal to W. Is there any answer like that? W and Y are equal. X and Z are equal. A is your answer. Let's move ahead. A parachute of 80 kg falls at a steady speed of 10. The gravitational field strength is this. What is the upward force on the parachute? Very, very easy. Let's say this man is a parachutist, okay. He is moving at a steady speed. By a steady speed, this means that the downward force of weight will be equal to what? Will be equal to the upward resistive forces. Weight will be equal to the upward resistive forces because you are traveling at a steady speed and at steady speed the resultant force is equal to 0. What will be the weight here? 60 kg multiplied by the gravitational field strength, that is 10. 600 Newton is your upward force. D is your answer. Let's further move ahead. A car is accelerating along a straight horizontal road. Okay, the diagram shows the forces acting on the car. Which forces are balanced? So basically, we have to apply Newton's third law here. Can you see the car is accelerating? One more hint. Can you see that the car is accelerating here? Yes. That means this driving force is greater than air resistance. So these forces wouldn't be equal to each other. So I can cancel out option C and option A and option D as well will get cancelled out. First of all, the only remaining option is this, so you will take mark this. Second of all, you can see this is basic Newton's third law. The force of action of weight is equals to the reaction forces occurring due to the contact between the tires and the road. Let's further move ahead. An engine truck at constant speed on a level track. Okay, the link between the engine and the truck breaks. Okay, so this link breaks. Okay, the driving force on the engine remains constant. Okay. So let's say initially there was a driving force of 1600. Now also the driving force is remaining 1600. Okay, what does this have? What effect does this have on the engine and on the track? Okay, on the truck. Okay, what effect will this have on the engine and on the truck? Yes, can you guess? The engine will speed up. The engine will speed up. Why? Because now there is the same amount of force pulling a lesser mass. The engine will speed up. Okay, let me give you an example. Engine before it was applying a 600 Newton force and engine pay after it is applying a 600 Newton force. Okay, have we studied the formula of F is equals to ma? Can you see force is constant? If force is constant, can I bring m to the downside? This becomes a basic inverse relationship. This becomes a basic inverse relationship. since this this truck has been eliminated from this engine, that means the mass has decreased. That means the acceleration for the engine will increase, it will speed up. A can't be my option, C can't be my option. What will happen to truck? It will slow down because now it will have 0 Newton force. Truck will have a force of 0 Newton, it will slow down. B is your answer. Let's see this. An apple falls from a tree. Which row describes the forces acting on the apple and the motion of the apple as it falls? Okay. So, first of all, if an apple, let me try and make an apple. Okay, let's say this is your apple, somewhat like this. If it is falling from a tree, first of all, the forces will be unbalanced because weight will be much greater, because initially the weight will be much greater compared to the air resistance. So the forces will be unbalanced. Secondly, due to unbalanced forces, there will be a resultant force which will lead to acceleration. C is your answer. Let's further move ahead. The diagram shows a block of wood resting on a sloping board. Okay, which arrow shows the direction of the gravitational force acting on the block? So, whenever you are asked about the direction of gravitational force, that basically means how will the weight act? So, how will the weight act? The weight always acts vertically downwards. A is your answer. Let's see this question. A force acts on a body. Which properties of the body may all be changed by the force? Okay. What does force changes on a body? Does it change the mass? No. Does it change the mass? No. No. Can it change the shape? Yes. Can it change the size? Can it change the velocity? Yes. D is your answer. Always remember mass can never ever be changed. Okay, let's see this. Four forces act at a point. Okay, what is the size of the resultant force? Let's calculate the resultant force. You can easily see that the up force is equals to the down force. So the resultant force in the vertical direction is 0. However, towards the right, you have 4 Newton. Towards the left, you have 8 Newton. So 8 minus 4, your resultant force comes out to be 4 Newton. B is your answer. Let's further move ahead. Okay, let's see this question. The diagram shows a block of stone on a rough horizontal surface. Force P acts on the block as shown. Okay. The block is at rest. Okay. A frictional force acts on the block. Okay. If you are applying a force towards right, the frictional force will always act in the opposite direction. That is towards the left, like this. That is towards the left, like this. Which shows the direction and size of F. Size of F will be same as P, and it will be towards the left. C is your answer. Why is the size of F same as P? Because both of these forces, friction and P, cancel out and the object remains at rest. That is, at rest as well, resultant force is equals to 0. Resultant force is 0 in two scenarios: constant speed and rest. Okay. So here we are considering the scenario of rest, the forward force equals to the backward force. Let's further move ahead. In which situation is the resultant force on the body equal to 0? Okay, in which situation is the resultant force 0? A car turning at a corner at constant speed? No. Here we will have a resultant force. If a car is moving in a circle, the resultant force acts towards the center. We have studied this earlier as well. A rock falling freely on moon? No. No. A train going up a straight hill at constant speed in a straight line. Wow, can you notice this constant speed? Whenever you have constant speed, resultant force equals to 0. C is your answer. Let's move ahead. A spacecraft travels from Earth to the moon. Okay. At a certain point in the journey, it has 0 weight. Okay. Why is the weight 0 as that point? Why is the weight 0 as that, at this point? The weight can become 0 if mass will never become 0. The weight becomes 0 if gravitational field strength becomes 0. Let's see which option makes gravitational field strength 0. The spacecraft leaves the Earth's gravitational field. No. The spacecraft stops moving? No. There is no air resistance? No. The gravitational fields of the Earth and Moon cancel out? Yes, this could be possible. Why? Because let's say Earth has a gravitational field strength of plus 5. Moon has a gravitational field strength of negative 5. Both of them will add up, give you a total gravitational field strength of 0. If gravitational field strength becomes 0, your weight will be equal to 0. Let's move ahead. Newton's third law describes a pair of forces which rho shows whether the two forces are of the same type and whether they act on the same object. So the forces are of same type according to Newton's third law, but they act on different objects. C is your answer. Let's further move ahead. The diagram shows only two horizontal forces acting on a trolley that is accelerating at this value. Okay. What is the mass of the trolley? Okay, so let's calculate the mass of the trolley. Your resultant force will be equal to what? 6 minus 3.6, that is 2.4. Okay, your acceleration is 0.12. F is equals to ma. 2.4 is equals to m into 0.12. 2.4 divided by 0.12. If you put it in the calculator, you will get an answer of 20 kg as your answer. C is your answer. Let's further move ahead. A block of wood is placed on a table. External forces act on the block, but the block remains stationary. Okay. If you are remaining stationary, that means your resultant force is equal to 0. A student suggests three conditions for the block to remain stationary. The resultant force must be equal to 0. Yes. The resultant moment must also be equal to 0. These two are the conditions for what? Equilibrium. These two are the conditions for equilibrium. The external force, no, this is not true. Which conditions are necessary for a block to remain stationary? Basically, what conditions are necessary for a block to remain in equilibrium? Only first and second. The resultant force must be equal to 0. The resultant moment must also be equal to 0. P and Q is your answer. Let's move ahead. A car of weight 11,000 Newton moves with constant velocity along a horizontal road. A driving force of 5,000 Newton acts on the car. What is the force opposing the motion of the car? Okay. So can you see again constant velocity? Let's say this is your Bugatti and there is a forward force of 5,000 Newton. But you are traveling at constant speed. What will be the backward force or the opposing force? Same amount, that is 5,000 Newton. A is your answer. A force of 1600 Newton accelerates a car of mass this from rest. Okay. What is the car acceleration and its velocity after 4 seconds? Okay. So you have the force, you have the mass. Can you calculate the acceleration? Yes. F is equals to ma. Your force is 1600. Your mass is 800. Acceleration will be equal to what? 1600 divided by 800 is equals to 2 ms minus 2. Your time t is 4 seconds. Okay. You have to calculate the velocity after 4 seconds. Initially, you are starting from rest. Your u is 0. Your u is 0. Your acceleration is 2. Your t is 4. Your final velocity will be equal to what? U plus 80. U is 0. Acceleration is 2. T is 4. This comes out to be 8 ms minus 1. Is there any option like that? D is your answer. Let's further move ahead. A car of mass 240,000 kg is traveling at a speed of this. The brakes are applied and it decelerates for 10 minutes until it comes to rest. Okay, what is the average resultant force? Very, very easy. What is your initial speed? 60. What is your final speed? 0. What is the time taken? 10 minutes. Can you calculate the deceleration? Yes. U is 60. V is 0. T is 10 minutes. 10 into 60, that is 600 seconds. What will be your acceleration or deceleration? Acceleration is equals to V minus U divided by T. What is V? 0. What is U? Minus 60. What is T? 600. What will your answer for deceleration come out to be? Negative 0.1 ms minus 2. This is your deceleration. Okay. If you are decelerating at this point, what will be your resultant force? F is equals to ma. Your mass is 240,000 multiplied by the acceleration of zero point 0.1. This gives you an answer of 24,000 Newton. Simple as that. A man with an open parachute is falling to earth at constant speed. The following forces are acting. Okay. The upward forces of the parachute on the man. Okay. The upward force of the man on the earth. Okay. The downward force of the earth on the parachute. The downward force of the man on the parachute. Okay. Which two forces are a Newton's third law pair? Okay. Very, very easy. Let's say this is a person falling with a parachute like this, falling with a parachute like this. The upward force of the parachute on the man, something like this. This will be acting on the man like this. Force P is equals to the downward force of the man on the parachute. Okay, so the man will apply a downward force somewhere here where its weight is on the parachute. So both of these forces are Newton's third law pair. Why? Because firstly they are equal, they are opposite, and they are acting on different objects. The force P is acting on the man. Force P is acting on the man, and force S is acting on the parachute. So P and SC is your answer. A man pushes a heavy box along the ground. Okay. A force acts between the man's hand and the box. Okay. Another force acts between the man's feet and the floor. Okay. So there is one force here, and there is one force here, and there is one force here. Okay. In which direction do these forces act on the man? Very, very easy. A man pushes a heavy box. So what will be the force at the hand? Towards the right. And another force acts between the man's feet and the floor. This will be the frictional force. This will act opposite to the motion somewhere here. So, what do we have to answer? Force on man's hand towards the right. So, we will cancel out A and B. Force on man's feet towards the left. C is your answer. What causes the frictional effects experienced by a cyclist to increase? Okay, what will cause the frictional force by a cyclist to increase? Using a lighter bicycle? No. Traveling at a greater speed? Yes. Frictional forces or resistive forces increase as your speed increases. B is your answer. Let's see this. A car is traveling forwards at high speeds. Okay. The brakes are applied and the car skids along the road surface. In which direction and where does the friction force act? Always remember that if you are braking a car, the frictional force will act backward. Whenever you are braking a car, the frictional force acts in the backward direction. A is your answer. Let's see this. A box is pulled up. So a box is moving up a slope as shown. In which direction does the friction act? Always remember friction acts in a direction to oppose the initial motion. To oppose the initial motion. To oppose the initial motion. So the initial motion is of moving up a rough slope. Initially, you are moving up a rough slope. What will be your frictional force? Downward in the same direction. D is your answer. Okay, a body slides down a frictionless slope. Okay, so there is no friction as shown. As the body presses on the surface, okay, the surface pushes back on the body. Okay, so there is a force that is pushing back from the surface on the body. Okay, in which direction does the surface push back on the body? Okay, so this is talking about contact forces. The block, you can say, yeah, body, you can say that this body pushes the surface like this. Hence, the surface pushes in an equal and opposite way, like this upwards. C is your answer. Let's see this. A skydiver is falling at terminal velocity. Okay, which row describes the acceleration of the skydiver and the velocity of the skydiver? So, at terminal velocity, your acceleration is 0 and your velocity is constant. C is your answer. Let's move ahead. The planets in the solar system orbit around the sun. Okay, which statement is correct? There is a force on each planet away from the sun? No. There is a force on each planet in the direction in it which it travels? No. There is a force on each planet opposite to the direction in it which it travels? No. There is a force on each planet towards the sun? Yes. Whenever you are traveling in a circle, the planets, let's say this is planet A, let's say this is planet B, all will act a force towards the center like this, like this. So always remember in a circular motion, the force acts towards the center. A free fall skydiver jumps from a plane. Okay. As he falls, there is an upward force acting and a force acting downward on his body. So the upward force is air resistance. The downward force is weight. Okay. These produce a resultant force. Before he reaches terminal velocity, how do the sizes of these forces change? Downward force stays the same because it is weight, so A and B will get cancelled out. Upward force increases because air resistance increases as velocity increases. And as air resistance increases, what will happen to the resultant force? It will decrease. C is your answer. Let's further move ahead. A skydiver falls from rest and through the air and reaches terminal velocity. What is the acceleration of the skydiver during the fall? What is the acceleration of the skydiver during the fall? It starts at 10 ms minus 1 and then decelerates to 0. Because in the starting you have only weight acting. So your acceleration will be 9.8 or 10 and then it will decrease to 0 as you reach terminal velocity. Here you reach terminal velocity. Simple as. Let's see this question. The graph shows how the height of an object above the ground changes with time. So basically you are given distance slash meters and time slash second graph. So this is a basic distance time graph. Just keep this in mind. This is a hidden way to say that this is a distance time graph. Okay. What is the terminal velocity? Okay, you have to calculate the terminal velocity. How can you calculate the terminal velocity? First of all, find a region where the graph of distance time gets a straight line. First of all, look for a region where the graph of distance time gets a straight line. Why do I say that? Because you must remember that the gradient of distance time graph is equals to speed. If you want a constant speed, or let's say constant speed is alternatively termed as terminal velocity. Terminal velocity is a constant speed. Let's say you want a constant speed, that then you will be looking for a constant gradient on the graph of distance time graph. And constant gradients are only possible if you have a line graph. So I have highlighted this yellow region which is a line. Here my gradient is getting constant. I can calculate the terminal velocity here. Let's do that. Let's pick 2 points here. This is your first point, that is x1, y3. This is your second point, that is x2.5, y0. Okay. What will your gradient come out to be? Y2 minus y1 over x2 minus x1. What is your y2? 0. What is your y1? 3. What is your x2? 2.5. What is your x1? 1. Negative 3 over 1.5. This equals to 2 ms minus 1. So your terminal velocity comes out to be what? Your terminal velocity comes out to be what? It comes out to be 2 ms minus 1. Is there any option like that? D is your answer. A planet orbits around the sun. The planet moves in a circular path at constant speed, but is accelerating because it is changes direction. Okay. In which direction does the resultant force act to cause this acceleration? Always remember, if you are moving in a circle, the resultant force acts towards the center. D is your answer here. Let's further move ahead. The diagram shows a car moving along a circular track at constant speed. Which arrow shows the direction of the resultant force? Again, towards the center. D is your answer. The diagram shows a satellite orbiting a planet at a steady speed. In which direction does the resultant force acts on the satellite? Again, towards the center. Always remember, whenever you are moving in a circle, the resultant force will act towards the center. Okay, this was an interesting question. A satellite orbits in a planet in a circular path as shown. It has constant speed. There is a force on the planet due to the satellite. In which direction is the force on the planet? Okay, you have to calculate what is the force on the planet, not on the satellite. The satellite will apply a force towards the center like this. According to Newton's third law, the planet will receive a force. A planet will have a force on itself in the opposite direction like this. See, up till now, if I can highlight this, you had to calculate the forces on the object that was performing circular motion, that is the satellite. But here, you have to calculate the force on the planet. This will be in the opposite direction to the force on satellite. If the force on satellite is acting inward, the force on the planet will act outward like this. Simple as that. Let's see this question. The Earth travels at constant speed in a circular orbit around the Sun. Which arrow shows the direction of acceleration and the direction of velocity of the Earth? So always remember, in a circular motion, the velocity acts in a tangential way. That is q. Direction of velocity should be q. P and r will get cancelled out. And always remember, in a circular motion, the acceleration acts towards the center. Always remember, in a circular motion, acceleration and force have the same direction, that is inward. So Q and R, is there any option like that? D is your answer. Let's see this. The diagram represents a moon around its orbit, moon in its orbit around the earth. Which arrow represents the direction of resultant force acting on the moon at that instant? A is your answer. A boy sits on a playground, roundabout carousel. What is the direction of the resultant force? Obviously, again, the resultant force will act towards the center. Y is the answer. The resultant force is in the direction of Y. Simple. Okay, let's get started with this question. Uniform horizontal beam pivoted at its right end is in equilibrium. Okay. A force of 60 Newton acts vertically upwards on the beam as shown. Okay, what is the weight of the beam? Okay, so if the beam is in equilibrium, the resultant moments will be equals to zero. By saying resultant moments will be equal to zero, what do I mean? Anti-clockwise moments will be equal to the clockwise moments. Okay, this 60 Newton force will cause moments in the clockwise direction. This 60 Newton force will cause moments in the clockwise direction. That is 60 into the distance, that is 50. And this weight will cause movements in the anti-clockwise direction, W into 30. What will your weight be equal to? 60 into 50 divided by 30. This becomes 1, this becomes 200 Newton is your answer. Simple. Just applied principle of moments. A uniform beam is pivoted at its center. It is pivoted here. Two weights are placed on the beam in the position shown, and the beam is balanced by an upward force F. Okay, so the beam is balanced by an upward force F. What is the size of force F? Let's find it out. The beam is balanced. Where was it written? Yes, here. This means anti-clockwise moments will be equal to clockwise moments. Let's analyze this. This 60 Newton force will cause a clockwise movement. That is equals to what? 60 into the distance from the pivot, that is 30. This is equals to 1800. Okay. This 30 Newton force will cause an anti-clockwise movement. That is 30 into 40 is equals to 1200 Newton centimeter. This is also Newton centimeter. This force F will cause a moment in which direction? In the anti-clockwise direction as well. That is equals to F multiplied by the distance from the pivot, that is 50. That equals to 50F. We know that anti-clockwise moments will be equal to clockwise moments. What are anti-clockwise moments? 1200 plus 50F. What is clockwise moment? Clockwise moment is 1800. Bring 1200 to the other side. 50F is equals to 600. F is equals to 600 over 50 is equals to 12 Newton. B is your answer. Simple as that. Let's further move ahead. Some forces are applied at different distances from a pivot. Okay. Which diagram shows the force that produces the largest moment about the pivot? Okay. So let's see which force produces the largest moment. This is 50 Newton force applied at a distance of 90 centimeter. So let's do one thing. Let's convert this 90 centimeter into meters. That is zero point 0.9 meters. 50 into zero point 0.9. This will give you 50 into zero point 0.9 will give you 45 Newton meter as your answer. 30 into 2 will give you an answer of 60 Newton meter. 18 into 3 will give you an answer of 54 Newton meter. And 80 into this becomes zero point 0.5 meters. 80 into zero point 0.5 will give you an answer of 40 Newton meter. So according to me, B is the correct answer, which has the largest moments. Okay. Okay, let's see this question. A horizontal beam is pivoted at x, okay, at x. A mass of 200 grams rests on the beam as shown. The center of the mass is 50 centimeter from the center of the right hand of the beam, okay. The beam is balanced. That means anti-clockwise moments is equals to clockwise moments. Can you realize that there is one force missing here? That is the force of weight acting downward like this. This will be 50 centimeter and this will be 50 centimeter as well because weight acts in the middle. Okay. And the distance of the weight from the pivot is this thing, this yellow highlighted thing. What will this thing be? 50 minus 20, 20. That is 10 centimeter. This is 10 centimeter. This weight will cause a moment in the clockwise direction. This mass will cause a moment in the anti-clockwise direction. So let's start the working. We know anti-clockwise moments is equals to clockwise moments. Okay. For anti-clockwise moment, what is your mass? 200 grams into the value of g, that is 9.81. That will give you your weight multiplied by the distance from the pivot, that is 20, is equals to, in the clockwise moments, what can you do here? In the clockwise moments, what can you do here? You can say that the clockwise moments are equals to what? Weight. That can be broken down into what? Mass multiplied by the gravitational field distance, that is 9.8. What is the distance? 10. Is anything getting cancelled out? Yes, 9.8. 9.8 gets cancelled out. I don't know why have I put grams here. This doesn't need to be here. And this is 1, this is 2. Your mass comes out to be 200 into 2, that is 400 grams. C is your answer. You might observe that I haven't converted my grams into kilograms or my centimeters into meters because, first of all, my final answers are all in grams. So, why should I convert this into kilograms? Secondly, the centimeters cancel out each other in the calculation of moment, so I didn't converted them into meters. Now, what do you mean by that, sir? Let me show you that. By that I mean, let's say if I converted 20 centimeters into meters, I would have to multiply it by 10 raised to the power of minus 2. Here as well, I will multiply it by 10 raised to the power of minus 2. Both will get cancelled out. Your answer will still come out to be 400 grams. That is the same here. A length of thread is attached to a lamina at point P as shown in the diagram. The lamina is free to rotate about point Q. The tension in the thread is F. Okay, so this is the tension. What is the moment about point Q? So you have to calculate the moment about point Q. This is the force. The horizontal distance between this force and Q is Y. Fy is your answer. C is your answer. Okay, let's see this question. The diagram shows a muscle and bones in a person's arm. The hand holds a weight of 40 Newton. The elbow acts as a pivot and the tension in the muscle keeps the lower part of the arm horizontal. Okay. What is the tension in the muscle due to the load? We have to calculate the tension T in the muscle due to the load. What will we do? We know anti-clockwise moments is equals to clockwise moments. This force will cause a clockwise moment. That is equals to 40 into 35. This tension will cause an anti-clockwise moment. Okay. So tension multiplied by the distance, that is 5. This becomes 1, this becomes 7. The tension is equals to 280 Newton. Again, you will notice here that I didn't convert it centimeters into meters because of the same logic. If I convert centimeters here, 10 raised to the power of minus 2 and 10 raised to the power of minus 2, they will both get cancelled out. If you are still confused why I am multiplying it by 10 raised to the power of minus 2, let's say you have 10 centimeters, you want to convert it into meters, what will you do? Usually in schools, it is taught to divide it by 100. That is similar to multiplying by 10 multiplied by 10 raised to the power of minus 2. Both of these things are similar. Okay, so let's move ahead. A uniform beam is pivoted at its center. The beam is balanced by three weights in the position shown below. What is the length of D? Okay, we have to calculate D. This 330 Newton is causing a moment of clockwise nature. So this becomes 350 D. This 100 Newton is also causing a moment of clockwise nature. 100 into zero point 0.5, this becomes 50. This clockwise is 50. And this is an anti-clockwise nature moment. 300 into zero point 0.4. 300 into zero point 0.4. This comes out to be 120. So what will we say? Anti-clockwise moments is equals to clockwise moments. 120 is equals to 350d plus 50. Let's take it to the other side. 70 divided by 350 is equals to your d, and 70 divided by 350 will give you an answer of 0.2. So is there any answer like that? C is your answer. Okay, let's see this question. The total weight of the load and the wheelbarrow is 600 Newton, that is acting downward. What is the size of force F needed to lift the loaded wheelbarrow? Very easy. Anti-clockwise moments is equals to clockwise moments. This 600 Newton will cause a clockwise moment. This F will cause an anti-clockwise moment. So F into 120 is equals to 600 into 70. F is equals to 600 into 70 divided by 120. This becomes 1, this becomes 5. Your answer is 350. A is your answer. Let's see this. Two stretched springs X and Y are attached to one end of a meter rule as shown. A weight W is hung from the other end. Okay, a weight W is hung from here. This weight will cause anti-clockwise moments. Okay. A pivot is at the center of the rule. Okay, so initially the system is balanced. Okay, the weight is moved towards the pivot. Now let's say the weight is here. Let's say the weight is here. What has happened actually? What has happened actually? Anti-clockwise moments were equals to force into distance. The distance from the pivot has decreased. That means anti-clockwise moments have decreased. Can you see that this? One second, let me do one thing. Can you see that the initial distance that is marked in blue, let's say di, was much greater than the final distance that is marked in green, that is df. Simple as that. So if your distance has decreased, your anti-clockwise movement will decrease. Okay. What will be the change in these springs? Okay. First of all, always remember in a spring, the tension acts away from the spring. Away from the spring. Something like this. These are your directions for tension. Let me zoom in a bit and mark it clearly for you guys. Always remember in a spring, tensions move away from the spring like this. T1, like this. T2. Okay. You can say tensions always move away from the object. Can you see that this T2 will create a which type of a moment? Clockwise moment. And this T1 will create an anti-clockwise moment. Now, which type of moments are decreasing? Anti-clockwise. So you need compensation or you need to increase tension 1. If you want to increase tension 1 to indirectly increase anti-clockwise moments, what will you have to do? You will have to increase the extension of the spring 1. Are there any options like that? Yes, C and D. We can cancel out A and B. Okay. And for clockwise moments, you have to decrease them to reach a balance again. If you want to decrease the clockwise moments, your tension 2 must decrease, your extension 2 must decrease. Any options like that? C is your answer. Simple logical physics. Let's move to the next question. A car is designed to be stable. Where must the center of gravity of the car be? As low as possible. The center of gravity for a stable object must be as low as possible, and its base area must be as wide as possible. Let's move on to the next one. Which object is the least stable? So, B, because B has the highest center of gravity. The diagram shows the children's wooden play tower, which change to the tower makes it more stable, making the tower narrower, making the tower taller, lowering the center of mass. Simple. Five blocks have the same mass but different base areas. Okay, they all rest on a horizontal table. A graph is plotted to show the relationship between pressure exerted on the table and the base area. Okay, so this is pressure versus area graph for a solid. What do we know? Pressure and area are inversely proportional. Inversely proportional. And what is the type of inverse proportionality? What type of a graph does inverse proportionality make? Let's say this is pressure. Let's say this is area. Inverse proportionality will always make a curve like this. So is there any option like that? D is your answer. Let's move on to the next one. Four table lamps, okay, are shown along with the position M of the center of mass in each case. Which lamp is the most stable? The lamp with the lowest center of mass. A is your answer. So this marks the end of MCQs for forces. If you have any further questions, you can ask me in the comments. Secondly, this PDF is attached in the link in the description. Thank you for watching.